room.
Jack.
Jack's not in my. Jack's not in. Oh, and Olivia from this morning.
Yeah.
Yes, Olivia. We are stranded in the library actually right now because they have overtaken my classroom with a state wrestling tarp that they are painting, and it is taking the entire room. So we are in the library. We're going to try to do this a little bit different. So bear with us. Homework assignment. 2 through 10 evens. This is page 441. 2 through 10 evens. 20 through 30 evens. So like 10-ish problems. 2 through 10 and 20 to 30. All evens. Evens. All the way through.
This is the second page.
Yeah. Is it on the second page? Poop. Sorry. Okay, so I'm gonna go all the way back to the beginning here. We've gotten through like example 2, I think. And I have a mess here, so let me get rid of this junk. I made a mess of this the other day. Okay. All right, so this is what we filled in on Wednesday, right? Because Wednesday was Friday. What? You don't need the sheet. But we filled in square, right? And rhombus, I guess. And we said that a square is the same thing as a rhombus and a rectangle combined, right? All of the qualities of a rectangle, a square has. All of the qualities of a rhombus, a square has, okay? But if you combine these two, if you combine these two things together, it makes a square. So if it's a rectangle and a rhombus, it has to be a square as well, okay? So let's go up to our examples and let's see what we've got. We are on page...
Miss Ma'am, do you have your keys?
No.
Where are they at?
In my room.
We're at here.
I don't know.
I'll bring them.
Can you not get in?
No, we can. But we're going to go to class.
Oh,
so
just
that
prop
you can
it.
Get back in. But we don't want other people to go in there.
I don't know where my key is. In my coat pocket, maybe?
Okay.
It's not my, like, lanyard key. It's, like, got, like, the...
Wrist thing?
Wrist thing. Okay. Example 3. Here we go. This one's easy. If it's a square, if this little shape over here off to the side is a square, and they say that FJ, this right here is 19. They want to know what FH is, this whole thing. Yeah. This guy has to be 19. 19 times 2. 38. 38. There you go. 38. That's it. Oh, it wasn't too bad. We also did the check down here below because this is a little bit harder. Okay, so let's look at the check. Let's see if we can figure this one out. All right. They say that this thing is a rhombus and PQ, which is 4x plus 3. So this distance right here is 4x plus 3. And QR, which is the right side, is 41. Yeah? So
We're
top side,
back
right
at
side.
lunch and finish it.
Okay. 4x plus 3 and 41. Got it? Then they also give us an angle, and they say PQT. PQT is this little top angle right here, and that is 2x plus 4y. And that's all they give us. And they say, what does y have to be in order for this to be a square? Okay. All right, here's the deal. They're giving me 2x plus 4y here. And when that happens, I tell myself, I gotta solve something else first because I can't solve for x and y at the same time, right? So I know that this is not where I'm going to start. Yeah? Where are we gonna start?
4x plus 3 equals 41.
Yeah, this has to equal this because those two sides are equal. So I'm gonna go 4x, I'm gonna do a little scratch work, equals 41, okay? And then this does not come out nicely. Minus 3, 41 minus 3 is 38, I think.
Divided by 4 is 9.5.
Divided by 4 is 9.5. All right, cool. 9.5. That's what x is. Now, I can use that and I can plug it back into this x right here. So this is 9.5 right there. Okay, now, here's the deal. This is this top angle. Do I know how big this top angle is right here?
45.
Yeah, if this is a square, then this has to be a 90-degree angle, and that's cut in half. So this would have to be equal to 45. So 2 times 9.5, I'm going to plug that in for x, plus 4y equals 45. That's what I've got going on here, and I'm solving. 2 times 9.5 is 19. Then if I subtract the 19 over, 4y equals 26. And then if I divide by 4, y equals 6.5. Yep. Yeah, 6.5. Okay, this Drives me nuts. You ready? Look at the answer choices.
You know it's not gonna be
We got the right answer, right?
Yeah.
The right answer is A. But guess what they also list as an answer choice?
90, 45.
No.
9.5.
9.5.
Oh.
And you know why they do that? Because you get this answer and you're like, oh, hey, I'm done. I see the answer choice, and you get it wrong. Even though you did all the steps right, you just haven't done all of the final steps. They do that so much on multiple choice questions. Like MAPS testing, ACT, they will do that to you. Be careful, make sure you've answered all parts of the problem, because if there's multi-steps to get to the final answer, and you answer the first one right, guaranteed they're going to list that as an answer choice, and you're going to think that you're done. Keep going. That's not the right answer choice. So 9.5, they're going to list it, but it's not right. So keep going all the way through. 6.5 is the correct answer. Okay? That's your warning. All right. Next thing, rhombus and square. Let's go down to not example 4. We're going to skip example 4, but let's do example 5. And this is the last one. And then, oh, no. We have 2 left. Example 5. Hello. He was... Yeah. We're just sitting family style, Brian. Sorry.
Huh?
I said we're just sitting family style, Brian.
Yeah, I guess I'm not in the family.
I'm sorry. Okay. So example 5. We've got 2 examples left. 5 and 6. We'll skip 4. 4 is a proof. This one says Anaya, whatever, is designing a sweater using the argyle pattern shown. All 4 sides are equal to 2 inches long. So this top is 2 inches. 2 inches, 2 inches, 2 inches, 2 inches. Okay? Does that mean this thing has to be a square? If all 4 sides are 2, does this have to be a square? Not necessarily, right? He could be a tilted square, which is also called a rhombus. He could be 2, 2, 2, 2, like that, right? So they are saying, what do we need to do to make sure that this is a perfect square?
Make sure the angles are 90.
We can. It's kind of hard to like measure the angles though. I mean, I could put like a sheet of paper.
Or-
Yeah, my husband does this like all day long. Like when he is setting walls up for a house that he's building, right? Have you guys seen houses that are built like, and then they have like their, I don't know, like the wall looks like this, and they have like the studs going through there, and then they put insulation in the middle, right? So what they do is they build those, and they put the boards in them that are like the walls, right? And then they go to set it up, right? Okay? And every once in a while, it's slightly tilted. Obviously not as tilted as this one, but like how do they figure out and make sure that it's not tilted like this? How do like they make sure that it's straight 90-degree angles like that? You just said it. What he'll do is he'll take a tape measure and he'll go from here to here, and then he'll take a tape measure and go from here to here, and he'll make sure that those are the same. Because if one of them's longer, like if this one's longer than this one, he'll like have to tap one side in and make sure that it's completely straight, right? Because sometimes it will be tilted. Not as tilted as this, because obviously you can see that that's tilted, but every once in a while it's tilted just ever so slightly that you can't even tell. But if he measures, he will be able to see that that is not a perfect square or a perfect rectangle, okay? So it says, how can she be sure that the argyle pattern is a square? Measure the diagonals. Because even though they're all 2s around the side, that only makes them a rhombus. I would have to measure the diagonals to make sure he's a square. Does that make sense? Yeah. Very good, very good. Okay. All right, example 6. We got to plot some stuff. Let's, I don't know, -3, +2. That's A. So plot these points. -3, 2. We've got -2, 2, 4, 6. -2, 6. We've got 2, 7. And 1, 3.
It looks like either a rhombus or a rectangle. And
Yeah.
more of a rhombus.
Yeah. So they are saying, is it a rhombus, a rectangle, a square, or none? Those are our choices. You think it's a rhombus? Okay. Let's see. How do we want to do this? Let's go No, we didn't do this morning. Let's go distance formula. Let's do the distances. You think it's a rhombus?
Yeah.
Let's do distance formula. Here we go.
Do distance of the.
Yeah, we're gonna do the distance of here. Make sure it matches that distance. We're gonna do the distance of here. Make sure it matches that distance. Got it? And then we're gonna do the distance of the diagonals. So we got like 6 distances to do.
Yay.
Okay, so I'm gonna do the top side, the bottom, the left, the right. Okay, top, bottom, left, right sides. And you might be able to do this without writing all this out. Okay, on the top, we're going from -2 to +2. That is 4.
4.
Okay, we're going from 6 to 7. 1. So you could look also like he's going over 4 and up 1. So 4 and 1. 4 squared is 16, 1 squared is 1. This is the square root of 17. Cool. Okay, let's do the bottom and make sure that matches. Is he going over 4 and up 1 also?
Yeah. Yes.
So 4 squared, 1 squared. Okay, which is the square root of 17. So top and bottom match. Awesome. They're the same length. Okay, the left side, let's say the left side. You can do the from -3 to -2. That's 1. From 2 to 6 is 4, right? He's going over 1 and up 4, right? 1 squared is 1. 4 squared is 16. That is the square root of 17 also. Okay? Same thing with the right side. He is going over 1 and up 4. Over 1, up 4. That's the square root of 17 also. So, he's a parallelogram because the opposite ones are the same, but better than a parallelogram. He is a rhombus, right? Because a rhombus has all 4 sides that are the same, right? Now we have to see if he's a rectangle or if he's a square. Because he could be all 3, right? If he's a square, he's also a rhombus and a rectangle, true? Yeah? So let's see if he's a rectangle. Now we're going to do what Aiden said. Let's measure the diagonals and let's see how far those are. Okay, it doesn't look like these diagonals are going to be the same, but we'll check and see. So, diagonal, let's go the furthest one first. Let's go this guy, okay? He is the -3 to +2 is like 5. And from 2 to 7 is also 5. So 5 squared is 25, 5 squared is 25. That diagonal is the square root of 50, whatever that is. Okay? The other one is going the short diagonal, which, I don't know, maybe it's not short. Maybe they're both the same size, but it looks short to me. Okay? From -2 to +1 is 3. From 6 to 3 is also 3. 3 squared is 9. 3 squared is 9. 9 plus 9 is the square root of 18. Okay, so what does that tell us?
It's not a square.
The diagonals are not the same, so it's not a rectangle, right? And if it's not a rectangle, it's not a square, right? What if it was a rectangle and a rhombus?
Then it would be.
Then it would be a square as well, right?
Yeah.
So if it's a rectangle and a rhombus, you have all 3, okay? If it's not a rectangle, it's not a square. It could be a rectangle but not a rhombus, then it's not a square, right? Mm-hmm. Does that make sense?
Yeah, because the rectangle diagonals are the same.
Yeah. So in this case, we just have a rhombus. Can you have none of the 3? Yeah, you could. If you had like a trapezoid going on or something, you know, it could be none of the 3. Okay? So there's that. We just did like the distance formula like kind of 6 times, I guess, ish. Top, bottom, left, right, make sure they match. All 4 of them are the same, so that means it's a rhombus. Check the diagonals. Okay? So there's that. Rectangle, rhombus, square, or none of them. There's your homework assignment if you need to see it again. Anybody have anything to add before I stop the video? No? All right, goodbye, everybody.